amplifiers and equalizers. It's really very interesting, and it's not that complex. Let's talk about what a basic amplifier is. So you've got an audio signal coming in, you've got an amplifier, you've got amp power, and you've got a speaker output. Okay, so you've got a signal input, very small signal in. You've got amp power, which is what you plug into the wall. That's got a lot of power coming from the power company. And then it goes to a speaker output. So let's see, how does this thing work? And essentially, it's a really simple principle. The electronics behind it is much more complicated, but in block diagram terms, it's a simple principle as to how it works. How does this work? Well, it takes the massive amount of power and it modulates it, controls it, as to how it goes out. So let's look at this whole system in words. An amplifier is a device that has an input, an output, and a power source, similar to a valve on a water hose, where the input modulates the power source to the output. A small amount of energy here on the input controls a large amount of energy and modulates it to the output. I've got a better example. You've got a water spigot. On one side, you've got the power supply coming in. On the other side, you've got the output, and the input is the turn knob that controls how much water gets out of the spigot. The power source doesn't change. The only thing that changes is the modulation of how much you modulate the power source to the output. It's kind of a cool concept, right? It's such a simple concept, but it's really powerful. That's how your guitar amp works. It's how your amp and your speakers work. It's the same principle. Actually, how to get there is what's also interesting. You can use tubes, you can use transistors. They all sound a little different, and I'll explain why. Let's look at a tube amplifier. This is what a basic tube looks like for people that have never seen a tube in a guitar amp. It glows and it gets hot. It warms up your room. It was actually originally evolved from a light bulb in 1906. First tube was used in AT&T networks, and vacuum is inside the tube. So they suck out all the air inside the tube, and then they've got a heating element, which is in the center, and they have what's called a grid going around the heating element. And let me explain it a little better here. Okay, so you've got a tube, and in England they call them valves, which is really interesting because that's really what it is. It's a valve. We call it a tube because it looks like a tube, and it is a tube, but the principle of the operation is a valve. So you've got an input, an output, and a supply. Now it just so happens that this guy here is made of a metal that's heavy with extra electrons. When I say that, I mean that the atoms are really big and have a lot of shells of electrons. And if you inject any energy into them, they tend to lose their electrons and they fly out of the orbits. If you remember a little bit about atom stuff, right? It looks like a little solar system going on, right? And the electrons fly off if they're too far away from the nucleus and the positives, and the electrons are negative. The way we inject a little energy into that is we heat it up. Heat it up with a filament, which is just a wire that has current running through it. It gets hot, it heats this piece of metal up, and in doing so, the electrons start flying off of it. Well, they fly off of it to this other plate on the other side, the anode, cathode and anode, and then in the middle here is this little dashed line. That's to represent a grid. What the grid is inside the tube is like a screen. It's actually called a screen. And the screen is a mesh of wire with holes in it. So the electrons can go through it, but when you put a positive signal on it, the electrons that are trying to move from the supply to the output, positive signal on the input attracts more electrons to fly off of the supply and end up on the output. When you apply a negative signal on the input, it repels the electrons from getting through. It can't get through because the input now is negative, which repels the electrons, so it can't get to the output. So you see how you can take the input and modulate a power source to the output by controlling the flow of electrons from supply to output. Simple principle, right? Really cool. You've got the anode here, and you've got the cathode on the inside next to the heater. The cathode releases electrons. It has to pass through the grid to the anode. the grid itself can be charged positive or negative, inhibiting or inspiring the flow of electrons from the cathode to the anode. And the reason that there's no air inside is because with all this heat, and you don't want the electrons to bump into air atoms as they're moving along, it would act more like a flash bulb, and it would oxidize very fast with all this heat and electricity flowing through the heating element if there was oxygen inside the tube. Without oxygen, it can't oxidize and flash like a flash bulb would. So they sucked out all the air just like they do in light bulbs. Drop an incandescent light bulb, it explodes because it's a vacuum inside of that. That's how that works. And it's a very simple principle, but it's really, really powerful, because what it really means is you take the power from Los Angeles Power Company coming out of the wall, and you modulate it, basically squeeze the wire or open the wire to allow more or less of the electrons to flow, and you're modulating it with your electric guitar signal. Except in a real amplifier for a guitar, there's multiple stages to do this, to get it really, really big so it can power your speaker, which has to really move back and forth and move air, because it needs a lot of power to get loud. When you want to turn up your Marshall to 10 and blow everybody's head off, it takes a lot of energy. But remember our discussion about transducers. It's taking electrical power out of the wall, and you're putting it through the system. Your electric guitar is playing it and modulating the electron flow. It's ending up at your speakers, which is making the speaker move and creating acoustic energy. So what you're hearing is really the energy that's coming out of the AC socket. It's been converted into acoustic energy. So it's been transduced.